Viewers, welcome to this video lecture series on computer networks. In this session, I shall explain an example on subnetting. In my previous sessions, I have given you the complete information on classful addressing, classless addressing, and the need for classless addressing. Once we say classless addressing, it is all about subnetting. So what is a subnet and how you are going to solve problems that are asked on subnetting. So the problem statement here, what I have mentioned, let me first read out here, then I'll explain the problem statement. After that, I'll start explaining you how to solve the problem. Here it is mentioned an organization is granted with a block 14.24.74.0/24. The organization needs to have 3 subblocks of addresses to use in its 3 subnets. One subblock is having 10 addresses, one subblock 60 addresses, and one subblock of 128 addresses. Design the subblocks and also find out how many addresses still remain unused in the organization. Here one thing I want to make it clear, subblock, subnetwork means the same, network and block means the same. So here it is mentioned that an organization is granted with a block of 14.24.74.0/24. When you use the word is allocated with a block is what? A set of IP addresses. Now here it is mentioned only the network address 14.24.74.0. But in this example, it is asked that you need to find out, suppose if this organization, there is one main organization, alright, this organization is granted with a block of 14.24.74.0/24. okay, this set of IP addresses. So the organization has decided that it will create 3 subblocks, or you can call it as 3 subnets. Also the organization decided that in one subnet they will have 10 IP addresses, in another subnet 60 IP addresses, and in the third subnet 120 IP addresses. You have to design the subblocks. So that means this is subblock 1, which is only 10 addresses. This is subblock 2, which is having only 60 addresses, and this is subblock 3, which is having 120 IP addresses. Organization block, you call it as block only. So the block is getting divided into 3 subblocks. One subblock will have 10, second subblock will have 60 IP addresses, and the third subblock will have 120 IP addresses. The question is design the subblocks. Design here is what? Design is you need to find out what is the first address in the subblock 1, what is the last address. How many number of addresses will subblock 1 have? How many number of addresses will subblock 1 have is already mentioned in the problem statement. Next, design subblock 2, you need to find out what is the first address, what is the last address, and the number of addresses that are existing in subblock 2, which is already mentioned, it is 60. And design the subblock 3, you have to write down what is the first address and what is the last address. To write the solution for this kind of problem, the very first step what you have to do is, first you need to design the main organization block only, because first you should know how many possible addresses or how many possible hosts this organization will have. So this organization, you are calling it as block, and you need to design this organization block. For that, first you check what is the block address given. Block address given is 14.24.74.0/24. So with this you can find out how many number of addresses this organization will have. There is one formula here to find out the number of IP addresses that this block can have. Just check the prefix value. Prefix value always denotes what? The number of network bits. Even this I have already told you, number of network bits. So here it is clearly indicating that there are 24 network bits. So out of 24, 8 are what? Host bits. So we can analyze in this manner also. 24 network bits are there and 8 host bits are there. Rather than analyzing in this manner every time, you have to make use of a formula wherein you can directly obtain the value for the number of host or number of IP addresses this block will have. The formula, and to denote the number of IP addresses, you are making use of uppercase n. So n equal to 2 to the power of 32 minus of n. This is the formula. And what is n indicating? N is indicating the prefix length here, 24. So in the given problem statement, n is how much? 24. The network bits you are always writing with lowercase n. The number of IP addresses or host you are writing with uppercase n. So network bits given in the problem is 24, n equal to 2 to the power of 32 minus of 24, which is equal to 2 to the power of 8, which is equal to 256. So 256 IP addresses are possible. Now from this 256 IP addresses, the organization has divided to form 3 subblocks. Let me try to show the same concept with a diagram so that it will be more clear to you all. For this problem, the solution, we need to first design the organization block, that is the main block here, or you can call it as the main network also. Sometimes in the problem statement block or sometimes network. This is subblock 1, or you can write subnet 1. And to design the organization block or the block network, first write down what is the block address. And remember, whatever is the network address or the block address, that becomes the first address in the block. So now you came to know that the first address in the block. Let us first design the main block or the organization block. Design the organization block. The very first thing what you are going to do is first note down as it is the network address that is given in the problem statement. That becomes the first address of the organization block. And moreover, to find out first address of the organization block, it is the first address is also called as the network address. Now to find out the last address, you need to first write down as it is the first address or any address that is given in the problem statement belonging to that network. Now it is first address only, so write down as it is 17. Then convert this into binary. In this case, 14 in binary will be how much? Here you have converted into binary. This is 14, this is 24, and this is 74, and this is 0. To get the last address, just check that 24 bits from the given IP address, you have to keep it as it is. So this is 8 bits, this is 8, this is 8. Up till here, you have to keep it as it is. Only the last, that means the remaining 8 bits, you have to convert it into ones. When you keep as it is all these bits, so I am writing it again. I am writing here to show that in order to find out the last address in the organization block, first 24 bits you are keeping it as it is. Why only 24? Because the prefix length given in the problem is 24. The remaining 8 bits will be ones. Now convert this back into decimal. This is 14, this is 24, this is 74, and this is 255. So now you got the last address here, 14.24.74.255/24. So that I'll write down here, 14.24.74.255/24 is the last address. Okay, this is how you have to find out. For the first address, all last 8 bits will be zeros in this case. For the last address, all 8 bits will be ones. Okay, so this is about the first step. Here you have designed the organization block. All this organization block will have how many? 256 addresses. And the second step is to design the subblock 1. You need to write the first address and you need to write the last address. Moreover, now though the number of addresses given were 10, 60 and 120, okay, for each of the subblock, when it comes to designing the subblocks, you should always start designing a subblock which is having the maximum number of IP addresses. So in this case, first we'll design a subblock which is having 120. Next time we'll go for subblock which is having 60, and then we will go for designing the third subblock which is having 10 IP addresses. And also, if a network or subnetwork is deciding for 120, always the number of IP addresses that has to get included in the network will be in terms of powers of 2 only. Now 120 is not in terms of powers of 2, so you have to make it the next nearest number which gives you in terms of powers of 2. It will be 128. Then 60 is also not in terms of powers of 2. The next nearest number will be what? 64. And even 10 is not in terms of powers of 2. So you are making it 16. So this way the organization has to now decide the number of IP addresses in each subblock. Or subblock 1 with 128, the next one with 64, and the next one with 16. So this is how you have to plan. Now start designing the subnet 1 or subblock 1. What should be the first address? Designing here is once again, as I already told, first address and last address of the subblock 1. first address, whatever is the first address of the organization block, that itself will become what? The first address in the subblock 1. So it will be 74.0. Now when it comes to slash, you cannot write 24 because 24 value in the prefix is giving you 256 addresses. But here you have only 128 addresses. So prefix value you have to write down correctly. Now how to write down correctly the prefix value? In this step what you have to do is, since you need to find out correctly the prefix value for the subblock 1, first write down n equal to how much? N is equal to 128. Because it was 120, you have made it 128 in terms of powers of 2. Now to find out the prefix length, you have a formula here, n equal to 32 minus of log to the base 2 128. Okay. Now the value for this will be 32 minus of 7, which is equal to, because log to the base 2 128 is 7, 32 minus 7 will be 25. So the prefix value is 25. That is why now you have to write down prefix value as 25. Right? The next number will be what? 14.24.74.1/25. Like this it keeps. Here you need to find the last address also. To find the last address, first note down the network address or the first address, 14.24.74.0/25. So 25 bits you have to keep it as it is. So here this 14.24.74 is covering 24 bits. So if I write it in binary and then once again convert back into decimal, it is same only. So I'll write down as it is. Only the last byte, which is 0. Initially I'll write down as it is zeros only, 1, 2, 3, 4, 5, 6, 7, 8. Now I will, to get the last address in this block, what I have to do is 25 bits are the network bits here. So that means your 25 bits of this IP address, you have to keep it as it is. 14 is 8 bits, 24 including 16 bits, 74, 24 bits. Then one more bit I have to take it from here. Okay, this one. Up till here I'll keep it as it is because the network prefix value is 25. 25 bits to be kept as it is. Then the remaining will be what? Ones to get the last address. Now convert this into decimal. Anyway, this 3 bytes we have retained it in decimal only. Now you have to find out for this what is the decimal value. It is, the decimal value for this is 127. 127, and now the prefix value is what? 25. So here in the diagram also I'll write down the last address will be 14.24.74.127/25. This is how you have completed designing the subnet 1. Your first address is here, your last address is here, and the number of addresses is here 128, and this is the prefix value. These 4 details, okay, will give you the complete information about any subnet. Next comes the subnet 2. Now subnet 2 also you should start writing the first address. Here to write down the first address, wherever I have ended here in the first subblock 14.24.74.127, this is the last address in the previous subblock. The next in the list will become the first address in the next subblock. So it will be 14.24.74.128 slash I will not write 25 because 25 value is giving you how many addresses? 128. But now your subnet should have only 64 IP addresses. So the subnet value also I need to find out. So let us design the subblock 2. N value is 64. Okay. So you can write down the prefix value. You can find out the prefix value with this. How much it will be? 32 minus of this log to the base 264 is 6. So n equal to 26. So you got prefix value as 26. That means your network bits now will be 26. So in the subblock 2/26. The next number will be 14.24.129/26. Like this it will continue. Now you have to write down the last address. So to determine the last address also follow the same procedure. As first note down the address, first address here, which is 14.24.74.128. Convert this into binary. So I'll write it here 24.74.128. Find this in binary. If you convert, slash 26 is the value. 26 bits you have to keep it as it is. So 14, 24, 74. These many bits, 24. 2 more bits I require. So only for that I will expand this 128. I'll write this in binary. 128 is 1 followed by all zeros. To keep 26 bits as it is, what is that I have to do? This one. These bits as it is, the remaining bits I'll make it ones. So this way I can get the last address here. These bits I'm keeping it as it is. Now convert this part into decimal. How much you will get? 191. So I got this address. Now the same thing, I'm just writing the slash value also, 191 slash 26. So this becomes your last address. I'll include here in the diagram. So the last address is 14.24.74.191 slash 26. Now the thing is, you have to design the third subnet, and last IP address in the previous subnetwork has ended at 191. So now the first address in the next block will be 192. 14.24.74.192 slash. Once again, I should not write here 26 because 26 was giving me 64 IP addresses. And now I have to see that for 16 IP addresses, what will be the prefix value. So for that I should design the subblock 3. N value is 16. So prefix value will be how much? 32 log to the base n. 32 minus 4. 32 minus 4 will be how much? 28. So the prefix value what we got is 28. So that prefix value I'll add now here. So this is your prefix value. 14.24.74.193 slash 28 will be the second address, 194 third. Like this it will continue. Now you have to find out the last address. So for the last address, what is the procedure? Note down the first address in the subblock, convert that into binary, keep 28 bits as it is, and the remaining bits you have to keep it all ones. So the same thing we'll do now here. I'll write down 14.24.74. The first address in this subblock was 192 slash 26. To get the last address, I have to keep 28 bits. So to get the last address, 28 bits I have to keep it as it is. Remember, for me 28 bits I have to keep it as it is. So 24 are getting covered in the first 3 bytes. I don't have to convert that into binary. The remaining 4 bits are coming into the last byte. So for that reason I will convert only the last byte into binary. Okay, and to get the last address, the procedure is keep all the 28 bits as it is. 28, 25, 26, 27, 28 up till here. Okay, up till here I have to keep it as it is. The remaining 4 bits I have to write all ones. So now convert back again to decimal. What is the decimal value for this? 11001111. It is 207. Okay, and now add the prefix value also. It is 28. So this is your last address. Hope you got to know. You are always taking the first address, okay, from the subnet, following this procedure. What procedure? Keep 28 bits as it is, and only what the last 4 bits you have to write all ones, so that you will get the last address. So now the same thing I'll write here. 14.24.74.207 slash 28 is the last address. Hope you got to know now how to design the subblocks. So first we decided with the first main block only, the network block. First address is 14.24.74.0 slash 24, 14.24.74.1 slash 24, like this. Okay, and finally what is that last address is 14.24.74.255 slash 24. Now out of this complete 256 addresses, from that 256 only first 128 are given to the subnet 1, 64 are used in forming the subnet 2, and 16 addresses are used in forming the subnet 3. The last part of the question says that find out how many addresses still remain unused in the organization. That is very easy. How will you find out? Because you know now that 256 addresses were assigned to the organization. Out of that 256, 128 addresses were used in the subnet 1, 64 addresses are used in subnet 2, and 16 addresses are used in subnet 3. So totally how many addresses the organization has used? 128 plus 64 plus 16, 208. Out of that, out of 256, 208 are used, so you have to subtract 208 and the remaining will be 48. 48 addresses still remain unused. For 128 the prefix value was how much? /25. For 64 the prefix value is /26. For 16 the prefix value is /28. Is for the total number of addresses in the organization, it is 24. So this is what you have to take care whenever you are designing the subnetworks. You should write down correctly the prefix value also. For the main block you got the prefix value as 24, but for the subblocks, first one, because see, for 256 addresses the prefix value is 24. 24 bits are ones, the remaining 8 bits are zeros. 2 to the power of 8, 256. Here for 128, 25 bits are ones, the remaining 7 bits are zeros. 2 to the power of 7, 128 is the number of addresses. Next, for 64 addresses, 26 bits are the network bits. So 26 bits are network bits, means only 6 bits are zeros. 2 to the power of 6 is 64. Then for the third subnet, 28 bits are network bits. All 28 bits are ones. The remaining 4 bits are zeros. So you will have only 2 to the power of 4, 16 IP addresses. So as and when you see there is a difference in the count of IP addresses, the slash notation will also get changed. So this is how you need to solve the given numerical. Here I would like to tell one more information. Already I have made a video lecture on this particular example. So the title of that video lecture is Example on Subnetting. So there, same example I have solved it, but there is one mistake that has happened. Instead of writing the last address of the first subnet has to be 14.24.74.127. So instead of 127, by mistake I have written over there 128, and since I wrote 128 as the last address of the first subnet, the first address of the second subnet has become 14.24.74.129. So these are the two errors that has happened in that video, and also I have written in the description of that video the correction statement. So what exactly I wanted to tell is, when you are calculating the last address of any subnet, you have to carefully calculate and write the correct address so that the first address of the next subnet will also become correct. Hope you find this information useful. Please like, share and subscribe to my channel. Thank you. Bye bye and take care.